Hi everyone, welcome to the Civrays InMoov. If you were watching the last video, you'll saw that we tore the robot down. I basically removed the arm that was attached and removed the head and took the robot off the stand, so we just had the bare torso on the bench. I then also stripped down the stomach assembly that we'd built up in a previous video, just in preparation of getting it attached to the torso, and we actually made a start on that attachment by getting this front section you can see here in place and the section behind it with all these dovetail joints that we all love. Yeah. What I'm going to be doing in this video is hopefully continuing with that, and I'm going to try and rebuild up the top stomach assembly, I think is the right name for it, the top stomach, and get that attached in here with the grease and ball bearings in these grooves here. Now I mentioned last time when I took it apart I heard a bit of a crack, and we actually found that we'd actually broken these square studs off of here, and I think when I was talking about it I actually got it slightly wrong and said that the square studs are on this piece, and they're not. These are actually the square holes. They go right through to the other side. You can see there the holes. So it would be possible to repair it properly and clear out these square holes, just get rid of the broken bits, clear them out. This part is actually fine. I'd have to reprint this part again with the square studs in place and then reattach it. However, I don't think that's necessary because I've been looking at this and I can put that on there and they still have some effect. They still prevent this from rotating. And also there are two screw holes in the back that we can use, and that's probably some of the reasons for the failure. I didn't fit any screws in here. If I'd have put the screws in there it probably would have held it a lot more securely and it probably wouldn't have broken. However, I think just fitting the screws in there is probably going to be good enough. That brings me to my next problem. I don't have any screws that will fit in those holes. I think what we really need is M4 countersunk screws. I think it's important on the front, which is this one, that they are completely flush, because we have the NeoPixel ring that sits on top of it, so these screws need to be fully recessed, fully flush. On the back it's not quite so important. I don't think there's anything on the back that would be affected if the screws protruded a bit. Now what I've got is these M4 screws here, but they don't have a countersunk head. They just have a normal pan head, and what I'm going to try and do is just open up the recess a bit, countersink it a bit further, and hope I can get the head right below the surface, and I think that'll be good enough. But we should really use countersunk screws. I have to stress again, this is why it's so important that we document what screws are needed to build an InMoov, because there's so many different screws you need, and you come to a part of the build and you don't have the screw you need. You can always order it, but then it's going to take time to be delivered, which is my problem here. I have actually ordered some M4 countersunk screws for this, which I could possibly replace in the future, but I just don't want to wait for them. I want to press on and get this built. So I think the thing I'm going to start with is try and get these screws in. I'm going to open up these holes a little bit so that we can sink the heads down. I'm going to try and get these screwed in. Okay, I've screwed them in. I'm not 100% happy with that, and I wouldn't recommend you follow that approach. What I've done is just opened up the holes so that I can get the head right under the surface. The problem with doing that is you actually remove all of the surface plastic and you're really just screwing down onto the infill, so that is far from ideal. I think it'll be okay. I mean, if it breaks we'll just have to reprint the parts, but these still really aren't the ideal screw to be using. You shouldn't really be using a machine screw like this. We should be using a self-tapping screw. I think really the holes in the round parts are a little bigger than what would be ideal. They're just slightly too big for M4, so as I'm tightening the screws up the threads are kind of stripping off. They're okay. I think it'll be good enough, just not really ideal. I think the next stage would be to actually get the grease and ball bearings in. As you can see, we have this one to go on the back. It's going to be the trickiest one because we have the gear on this one. So I might just try it in as a dry fit first, and once I'm happy with it, I'll just have to remove it, put the grease and ball bearings in, and then refit it. I think then once we've got that one in, we can put the front one in on top. You kind of have to work upwards, so the ball bearings will sit in this piece. We'll fit the torso onto that, and then we'll put the ball bearings on the top of the torso, and then finally we'll fit the front piece. So let's give that. Okay, so I've got the ball bearings in here. I put a layer of grease into the groove and then just put ball bearings in there, just stick them into the grease. I've turned the torso over, so this is actually the back of the torso, and I've put grease around here. I've also tried to get it on the inside of the circle, and I've put a little bit on the gear as well. I guess we could add a little bit onto this gear. Don't think it's terribly important, but it doesn't hurt to have grease on there. And I think also it wouldn't hurt to have a little bit of grease around the the circular part here, because it just rubs on the inside here, so a little bit of grease make it easier to rotate. The only thing I'm not happy with is I moved the gear, so now I really don't know if the gear's in the centre or not. I should have maybe marked it somehow so that we know where the centre is. I was thinking that I could maybe get a variable. I could get a sort of a multimeter and measure the resistance in the wires as I turn the gear, try and figure out where the centre is, but I really can't be bothered. I think I'll just pop it in and hope it's roughly in the centre, and we can probably just make adjustments in the software. Okay, I'll show you what I was attempting to do. I actually bought these syringes, and I thought it would be easier to suck some grease up into the syringe and then use that to just control exactly where I want the grease, and it partially worked. It works once you got it into the tube, but I found it's really difficult to get the grease to suck up into the tube in the first place. So it's a good idea, but not a total success. Best to buy the grease in tubes, I think, where you can easily dispense them. I've just got this big tin, and it's a real pain in the butt. Anyway, we've got grease around there. I've got the ball bearings on the front here. I did again run a little bit of grease around the inside of the circle, so I'll refit that on there now. So I'm just pushing the front piece down, and I'm trying to show you that you need to get it to locate into two little lugs in there. So the back part and the front part need to lock together so that they don't rotate independently. We are going to run a bolt through the whole thing, but it's important that there's two little lugs inside there. I think you just see one here and one over that side there. They need to locate so that this gap that we can currently see can close right up. I'm actually using a 90mm cap head M8 bolt to run right through. That's just like this, 90mm long. We'll run that through there, and we'll put a nut on the back. And I'm fitting an M8 nylock nut on the back, so hopefully it won't work its way loose. So I don't normally get my socket set out, don't get much use for that, but it's quite handy in this case. So it's an M8 nut, so we need a 13mm socket wrench to tighten that up. I'm not sure how tight we want to go with it. We may have to play around with it to adjust the tightness. So it's on there. I'm not sure how happy I am with it. I don't know if you can hear it, but as I rotate it, you can actually hear the grease squelching around. And you probably can't hear that, but I'm sure when we've got the noise of the servo motors we won't hear that at all. It feels reasonably smooth. It's kind of a little sticky to get it moving, but once it's moving it moves quite smoothly. Hard to say really whether I'm entirely happy with that, but we'll press on. So I think the next stage is a little fiddly and tricky, so I'm probably going to have to do quite a bit of this off camera. Basically we have to thread these pistons into the blocks that we've got in there, so they'll need to thread into these. I'll need to kind of thread them in together so they go down at the same kind of rate, and we'll gradually bring the torso down so that these parts will fit into the square holes here, and there's two more on the back. You kind of need to gradually wind it down so that moves into the base. Probably better to do that standing up, maybe get it started lying on its back and then stand it up. Not sure if it's a good idea or not, but I've added a little bit of grease onto the top of each piston, so as I thread them in I'm kind of hoping that'll spread round a bit. I think we can actually get to the sides afterwards, and we can probably add a little bit more grease if needed. You probably don't need grease, but I think it might help with the noise a little bit. So what I did, starting with it laying down, I've stuck something under it. There's a tape measure under there to just sort of raise it a little bit, and then I can start to thread the first one in like that, just to get it going, and then we can bring the second one in here, start to thread him in as well. It's a case of winding them in together. I think they need to turn in opposite directions and it will pull the assembly up into the torso. So now I've got it started, I think I'll stand it up. And then we'll have to try and locate these into these holes as we lower it down. So I'm turning the pistons in the opposite direction. I'm going to have to get the back ones lined up as well. Sorry, I can't show you the back and the front at the same time. So the front one's lined up. Just spin it around, maybe you can see it. The back one looks okay as well, actually. Front popped out. There we go, the front one's in. You kind of just have to keep just doing a little bit and pushing it down and turn a bit more. I think it's nearly there now. The back seems to be fully down. The front's a little harder to see when it's in, because with the back you can kind of see at the sides if there's a gap underneath. But on the front it just looks like it's in, but if you kind of look down the back you can see it's not. It's fully down now. So I think what I would normally do next is fit screws in the bottom in these 4 holes here, but I'm actually going to screw right through my stand and use these as 4 fixing holes on my stand. At least that's the plan. I guess I could do that next. I mean, we do have to attach the NeoPixel ring, but I think I might get it on the stand and then proceed from there. So if we now turn them in the same direction, it will tilt one way, and turn them the other way, make it tilt the other way. There's still some creaking, and I'm not really sure where it's coming from. It must be plastic rubbing against plastic, but it's hard to tell where the noise is coming from. Even though I did put grease on those pistons, I only put a tiny bit on, and they feel dry, so I guess probably could do with some more grease on the pistons. I'm not too bothered about the noise at the moment. I can maybe solve things like that with a bit of fine tuning later. I had a horrible feeling then. I had it on back to front, but it does look the right way around. So I've attached it onto the stand by running the screws through here. They're going all the way through the piece of wood and up into this piece here. Feels pretty sturdy. The stand itself is a little wobbly, but I think he's attached quite securely to it. I think what I'll do now is I'll reattach the NeoPixel ring. I've only put 2 screws in. I'm not sure if I'll need to remove it again, so I don't want to put them screws in if we're going to keep taking them in and out. This is actually going together really nicely. I guess we should really give the stomach a quick test, but I'm very tempted to start attaching the arms. So just for my reference, because I'm sure nobody else is wiring their InMoov up like this, I've got my NeoPixel ring on this small grey ribbon cable, and I believe there was an arrow on one of the connections on the plug, and from memory, and I will go back and check, I think the arrow was the ground, and I think I designed it so that the ground is the black rail on my headers, which is near the outside of the circuit board. I think generally that's common practice to put your grounds on the outside of the circuit board. We then have this new wire here, which is the potentiometer for the stomach tilt, the tilt side to side, the mechanism that we've just built. So that's the potentiometer for that. And we've now got a plug on that, so I've plugged that onto the header there. I've left one gap, so we've got the servo control wire and power on the first connection. The space that I've got in there is for the stomach rotation servo control and power, which we haven't built yet. And then the next 2 connections are just jumpered together, so I can plug my header that my plug that I've built up onto one of them, and then we'll have to terminate these cables here, which are the potentiometer connections down in the servo. I have to terminate them with a plug and put them on the next connection just next to it. So I think they'll be on J and K are just jumpered together. So I've hooked this up to MyRobotLab. You can see we've got MyRobotLab running there on the laptop. I've got an Arduino here with the MRL-COM Arduino sketch running on it. And I've just got it running off my little LiPo battery as always through the voltage regulator. I was trying it with this little servo here. It's working fine. So I've connected it through this extension cable and up to our servo. And it seems like wherever I set the servo in the MyRobotLab software, whatever position I set it to, the torso always wants to move over to one side. It's always going over to the same side. So my thought was the potentiometer must be connected back to front, Now we did have this working before, but I do remember that I put a new cable on the potentiometer, so I may have messed that up. And I was just having a look down here at where I've got this connected onto the board, and I've realised that I've connected one back to front. The yellow wire that we can see here should be on the other side, and the green wire, which is sort of to the back, that's the darker colour, so that should be on the outside, on the black rail of these connections. So that's back to front, so that's probably what the problem is. So I'll just move that around. So I swapped that over, corrected that little mistake there, and that is now, seems to be working. It's set roughly in position 90. I'll see if I can just bring the laptop around a bit. Sorry, we can't see the screen very well, but it's here, roughly in the centre position at 90, and we can see the torsos. I can see it because I'm standing a bit further back, but the torso is ever so slightly leaning over to this way, but it's pretty close to the centre, so that pot must be fairly close to centre. I don't think it's possible to actually get it into the centre because of the teeth on the gears, but that's basically working. And now it's a little tricky for me to do this, but if I try and move that, see, that's going over to one side. If we move it back, coming back over to this side, that's really creaky. It is working nicely, just that creaking noise is a bit. Definitely working, it's just a little annoying how much it's creaking. I'm going to try and add a little bit more grease to those pistons. So I've added some grease to it. It kind of feels like the noise is coming just from this one side. The other side doesn't seem quite so bad. The other area I thought the noise might be coming from is the main circular piece inside here. We can just about see it down there. That's plastic rubbing against plastic, so that could be making some noise if we haven't got grease on that. I think maybe those were a little bit of a too tight fit. I am a little worried about it because it really sounds terrible, and I'm thinking something's probably going to break, which is quite disappointing when you spent all this time building up to this stage and then something breaks. I'm quite worried about the pistons because I don't think they're particularly very strong. I'll try and get the camera on the tripod, and then I'll move it a couple more times so you can have a listen to it. When it's moving fast, it sounds fine. It's when it's moving slow, when it's sort of coming to a stop, when it really makes the noise. So it'd be really good to get somebody's feedback on that. If anyone's had a similar issue with that, it'd be really good to know if there's any way we can resolve it. So I tried to improve it a little bit. I removed this piston. You can just about get it out without dismantling everything. I degreased it, and then I sanded it with 180 grit sandpaper, then 400 grit sandpaper, and then 1000 grit. I re-greased it and put it back in. I think it's slightly better, but the problem's definitely still there. I'm not sure I'm going to be able to solve it, so I'm just going to carry on and ignore it. I've been playing around with the mappings a little bit in MyRobotLab. I know you can't see the screen, but they're down the bottom here. So they're down the bottom right of the screen. There's the output map, and I've set the top figure to 72 and the bottom figure to 128. And then if I slide the slider all the way down to 0, I've kind of set it up so that the bottom of the torso sort of meets with the corner of this piece here. It can go a little further than that, but I'm not going to push anything to the limits. And then if we swing it right the other way to 180, I've done the same on the other side, so the torso just meets on this corner. Again, I think it will go. No, we're pretty much right at the limit there. And then if I swing it to 90, it should come to the center. But what I've been finding is, I think because of this creaking problem, it's struggling to move slowly. So when it tries to get back to the center, it kind of struggles to get there. If you approach it from this side, you don't quite make it. And if you approach it from that side, you don't quite make it. So you'll be leaning slightly that way. So it doesn't really matter how I move it. It just struggles to get back to the center. I think it is set up correctly. It's just that it's struggling to move slowly. And that's because of this creaking issue. I think the plastic kind of sticks when it's moving slowly, so it's not sliding nice and smooth. So it's struggling to get there, which is probably why we can still hear a bit of a hum. The servo hasn't quite, the potentiometer hasn't quite reached its final position. It's still trying to move the servos, but they can't quite overcome that friction. The video's getting a bit long, so I think we'll leave this one here. What we'll do next time when we come back is we'll start looking at the shoulders. I'm very tempted to just bolt them on and rush through it, but I think it's important to just take our time and look at each servo setup, each potentiometer setup as we do it, so that we know that when we're installing the shoulder, it's going to be good and we're not going to have issues with it. We're not going to have to take it out again. So it's tempting to rush, but let's just take our time. So, as always, thanks for watching. If you haven't done so already, please subscribe to the channel. I'm really trying to build up my subscribers. And we'll see you next time.